Hello everyone, my name is Sanjeev and today we're looking at SAT Math, Geometry and Trigonometry, specifically circles. And as always, we have a set of 5 hard level difficulty questions. Let's get started with our first one. Our first one says, a circle in the xy plane has its center at negative 1, 1. Line T is tangent to the circle at the point 5, negative 4. Which of the following points also lies on line T? So whenever we get these coordinate geometry type problems, we always have to try and draw a coordinate plane in order to try and see how this problem fits together. So again, this is not my best drawings ever, but it'll be fine. So we have negative 1, 1. That's actually, well, let me do this one quick second. Okay, yeah. This will probably be about as good as I can get it. But, yeah. And then we had the point 5, negative 4. 1, 2, 3, 4, 5. 1, 2, 3, 4. So around here. And we know that both of these are points on the circle. How do we know this? Well, what is a tangent line? A tangent line is a line that touches the circle or whatever it is at only one point. And that one point is 5, negative 4. So that means that 5, negative 4 is both a point on the circle, but also on the tangent line. So let's try and draw the circle as best as I humanly can with the conditions I'm working with. So again, this is your point right here. And tangent line would look kind of like this. So if we look here, if we draw a line from the center to here, and again, this is not a perfect circle, but if this was a perfect circle, then the tangent line would be perpendicular to our line that forms our radius. Okay, so based on that, we can figure out what we need to do. We have to first figure out the slope of our radius, and then using that, we can figure out the slope of our perpendicular line, which is tangent, and then after that, we can figure out what is the equation of the actual line, and using that, we can figure out which of the points lies on line T. Okay, so first we need to figure out the slope of our first line, which is our radius. So our first line has our points negative 1, 1, and also the point 5, negative 4. We just need to use our slope, which is delta y over delta x, which leads us to 3 over 6. Oh, this is negative 4, by the way. So always make sure to look at these problems like that. So this would be negative 5 over 6. Okay, and that would be our slope, right? X is increasing by 6, and y is decreasing by 5. So this is our slope of our radius. However, we need to find the slope of a tangent line. Now, remember, our tangent line is perpendicular to the radius. And when you have a line that's perpendicular to the other line, the slope is going to be the negative reciprocal of the other line. And I believe I talked about this in a previous video as well. So we take the negative reciprocal, will be 6 over 5. Right? So we can then set up the equation of the line, y is equal to m, which is 6 over 5, x plus b. And we do not know what b is, but we can figure it out. And how can you figure it out? Well, we know that the line T is tangent to the circle at the point 5, negative 4. And we know that 5, negative 4 is on the tangent line. We can plug in 5 for x and negative 4 for y and figure out what b is, right? So negative 4 will be equal to 6 plus b, and then b will be thus equal to negative 10. Now all that's left is plugging in our values of x and y and figuring out which of these matches up. So if we plug in 0 for x, we're left with negative 10 for y, which is obviously not 6 over 5. If we plug in 4, we're left with 24 over 5 minus 10, which is definitely not 7. If we plug in 10, we get 60 over 5, which is 12. 12 minus 10, which is 2. Oh, and look at that. That's what our y value is, and that would be our answer. And that's all we need to know, and we move on. Moving on to our next problem, it says the circle has a center O, and the length of arc ADC is 5 pi, and x is equal to 100. What is the length of arc ABC? Okay, so before we can go about solving this problem, we need to first figure out what is arc ADC and what is arc ABC. So what is an arc in the first place? Or what is, in this case, what is the length of an arc? So the length of an arc is actually a portion of the circumference. So if we look at ADC, we'd start at A, we'd go to D, and then C. So this would be arc ADC. And then length of arc ABC is the remaining portion of the circle right here. Right? So what we can do next is we can figure out what is the total, well, okay, before we move on, we need to figure out, we know that ADC is equal to 5 pi, right? So as I was saying earlier, arc length is a portion of the circumference, right? So 5 pi is equal to something, so I'll just put x times our circumference. And what is our circumference? We do not know, but we'll put that as y. Okay? So remember, x is a portion, which is a fraction. So how can you figure out what this fraction is? Well, our fraction of our circumference is going to be the degree of the arc length divided by the total degrees in a circle, which is 360. And the degree of x in this case is 100, so it would be 100 over 360 times y will be equal to 5 pi, right? And using that, we can figure out what y is, which is then, remember, our total circumference. We can then subtract 5 pi from our y to figure out what is the remaining arc length. Okay, first we need to simplify this a bit though. So 5 pi would be equal to 10 over 36 y, right? And then this would be 5 over 18, right? And then multiplying both sides by 18 over 5, we get 18 pi is equal to y. And then we know y is our circumference, and ABC is just the circumference minus ADC. So we know that ADC is equal to 5 pi, so 18 pi minus 5 pi is 13 pi, which is B. Moving on to our next problem, it states that point F lies on the unit circle and has the coordinates 1, 0. Point G lies on the center, is in the center of the circle and has coordinates 0, 0. Point H also lies on the circle and has coordinates -1, y, where y is a constant. Which of the following must be the positive measure of the angle FGH in radians? Okay, keyword here is radians. Okay, so what are radians? Well, radians is actually the degree measure. It's just another way to express degrees, but usually it's used for stuff like polar coordinates or stuff like that. There's actually a conversion, and this is really important to know, and that is 360 degrees is equal to 2 pi, okay? Or 180 is equal to pi, okay? And then, 2 pi radians, I should put rad. So pi radians is equal to 180 degrees. Okay, so that's the conversion that you need to know. Okay, now we need to solve this problem, but remember, as I said earlier, whenever you approach a problem that has coordinate planes, or usually any type of geometry problem, whenever possible, try and make a coordinate plane. So if we have here, point F lies on the unit circle and has coordinates -1, 0. Point G is the center of the circle and has coordinates 0, 0. So this would be the center as good as I can do it. And 1, 0, that would be F, right? And it's a unit circle, so it has a radius of 1. So it'd be something like this. This is about as good as I can do it. So this point right here is F. One sec. F. Right? Point H is -1, y. So we have x is equal to -1. Well, we know it's a unit circle, so it has a radius of 1, right? And that means that the distance between the center and the point has to be 1. And given that the center is 0, 0, and this point right here is -1, y, we know that y has to be 0, so it has to be on the x-axis, in order to maintain that distance of 1. So this would be point H. Okay, and then this is G. So which of the following could be a positive measure of angle FGH? Okay, if we look around here, we see this is 180 degrees. Now, if we remember what I had said earlier, 180 degrees is pi radians. But if we look here, that is not an answer. Okay, why? Well, if it's not pi radians, then what is going to be our answer? Well, if we look here, if this point from this point is 180, and from here to here is 360, if we go another 180, we get back right to the same point. So it would be 360 plus 180. So that would actually be 3 pi radians. So it could be pi radians, it could be 3 pi radians, or so on and so forth, right? And if we add another 2 pi radians, which is again a full circle, we get 5 pi radians, which is also a valid option. Again, that's also not in here, but you see the pattern. We can continue adding 2 until we get the right answer. 7 pi radians, 9 pi radians, 11 pi radians, 13 pi radians, 15 pi radians, so on and so forth. Basically, all the odd pi radians would be the answer. So in this case, D is an odd pi radian, right? And that would be our answer in this case. So our answer is 25 pi, which is D. Oh, and before we move on with to our next problem, the reason this works is because if you're starting at one point and we're going a full 360 degrees, we're coming right back at that same point, right? And that's why this works. And this occurs for any point on the circle. Even if it was this point right here, if we go a full 360 degrees, we're coming back to that same point. That's why this works. So, in other words, this becomes really important, not just in the SAT, but also in like stuff like trigonometry and stuff, where you deal with sine and cosine and the periodicity of them. But that's a topic for a later day. But yeah, our answer is D in this one, and let's move on. Our fourth question says the equation above defines the circle in the xy plane. What are the coordinates of the center of the circle? Okay, this is also important. So when we have a circle, it can be outlined with this equation. X minus h squared plus y minus k squared will be equal to r squared. Okay, where r is the radius, h and k are the points in the center of the circle. H is your x coordinate of the center of the circle, and k is the y coordinate of the center of the circle, right? So if we look here, we do not have it in that format. So what are we going to do? We're going to have to do some algebraic manipulation in order to do this. Specifically, what we need to do is completing the square, right? So we look here, we can separate it out into x squared plus 20x, and also into y squared plus 16x. So when you have a quadratic in the form x minus h squared, what will happen if we expand this out? This will be equal to x squared minus 2hx plus h squared, right? Well, we know what x is, and what we're going to be doing is figuring out what h is. If you look here, we have 20x. So 20x will be equal to minus 2h. So that means that minus 20h is equal to, 20h is equal to minus 2h. So that means that h is equal to negative 10, right? So that means, looking here, one sec. Yeah. So what we have is x, minus of h, which is again negative 10, so that becomes h plus 10 squared. And then we do the same thing with y. So 16x will be equal to minus 2kx. Remember, all we're going to be doing is replacing this with a k. So this will become minus 2kx plus k squared, right? So we do the same procedure. We find out that k is negative 8. So y minus negative 8, and then this will become positive 8, y plus 8 squared. Okay, so we now have the basic left-hand side, right? So we have x plus 10 squared plus y plus 8 squared. However, what happened to our h squared and our k squared? Okay, this is where we need to expand this out. If we do this, we get x squared plus 20x plus 100 plus y squared plus 16y plus 64, right? And this is what we get when we expand this out. So that means that we have added a total of 164 to here, which we don't need, right? So if you look here, this is virtually identical to the left side of our equation, except it has a plus 164. So what this means is if x squared plus 20x plus, okay, by the way, we've already solved the problem, but I'm going to continue going on just to teach you how to express this in this term, right? If x squared plus 20x plus y squared plus 16y is equal to negative 20, that means that we're left with negative 20 plus 164. And then this would leave us with 144, right? And that will be our r squared. Okay, so that means that x squared plus x plus 10 squared plus y plus 8 squared will be equal to 144, which is 12 squared. Now, we had already solved this equation, so we had already solved this question using this right here. But our radius, which is r, is 12, so we're getting additional information. I'm just telling you guys in case it asks you, what is the radius of the circle, and it has this sort of problem. But anyways, remember, h is our x value of our coordinate, and k is your y value. So if minus h is 10, that means that h is equal to negative 10, and y is equal to negative 8, and this is x comma y, so we are left with negative 10 comma negative 8, and that would be our center of the circle, which is option choice B, and it has a radius of 12. So I kind of went above and beyond in this question, so that's fine, but hey, it's just you guys get to know something, right? And also, always make sure that even though you might have a plus 10 here, remember that your plus 10 is a minus h, right? So always be careful with your signs, because then you might be caught up and accidentally choose answer choice C when it's actually answer choice B. Anyways, moving on to our last question of the day, it states, the circle in an xy plane has a diameter with endpoints 2, 4 and 2, 14. An equation of the circle is x minus 2 plus y minus 9 squared is equal to r squared, where r is a positive constant. What is r? Now remember, as I was saying earlier, r is your radius. And again, we have coordinate plane. What are we going to do? We need to draw. I'll try and get this to red. So if this is 4 and this is 14, and we have the points in a circle, 2, 9, so that would be like, oh, I actually drew this wrong. This is 4, and this is 14, and this is 2. 2, 9 would be here, right? Ooh. Yeah, 2, 9, and then our diameter would be here. Okay, so how do you figure out what is, if we know that this is the diameter, right? We can just figure out what is the radius by figuring out what's the distance between these 2 points, and then just having that, right? If you look here, since they're just a straight line, this makes it super easy, and we can tell that the distance is just 10, and r is just half of that, which is 5, and that would be our answer, of course. But If you want to do this the harder way, like as if there wasn't a 2 here, there was like a 3 and this had something else, you just use the distance formula, which is just a modification of the Pythagorean theorem, right? It'd be the square root of x squared, it'd be, let me actually write that. It would be the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, and that's just coming from your Pythagorean theorem, just a modification of this using your coordinate geometry, and that's how you'd solve this problem. Alternatively, you can also use the equation of the circle, but that's kind of overkill in this sort of situation. So, yeah, there are multiple ways to solve this one, but the fastest one is just figuring out the distance and having it. And that's all I have for you guys today. Thank you very much, and have a great day.